Given a speed of 90 miles per hour and a horizontal distance of 264 feet, find the angles needed to hit a ball with that initial speed from 3 feet above the ground so that it hits that ground at that horizontal distance. So before we do anything, we have to first convert the miles per hour into feet per second for our function to work. 90 miles per hour multiplied by 5,280 feet in a mile divided by 3,600 seconds in an hour is 132 feet per second. Now, let's model our parametrics. T and A will be our variables. T for time, A for angle. For any similar equation like this, the parametric is as follows. X is equal to initial velocity times cosine of the angle times time. Y is equal to negative 16t squared plus the initial velocity times t times sine out the angle which it gets hit at plus initial height. Substituting in for initial velocity and height, which are right here, well, this is 132 feet per second, we get the following. X, because note that it hits the ground again at 264 feet. So the coordinate we are using is 264, 0. So 264 equals 132 cos angle times time, and 0 equals negative 16 times squared plus 132 time times sine angle plus 3. Let's do a substitution. So we know that t equals this from the above x when we moved this and divided it here. We just divided both sides. So then we plug that into the y parameter, and we get this. We simplify, because we got to turn the 2 over cos A into something. We know that 1 over cosine squared is equal to secant squared A. We also know that sine A over cos A equals a tangent. Let's plug those in. Negative 64 secant squared A plus 132 tan A plus 3. Note that secant squared A minus tangent squared A equals 1. So secant squared A equals 1 plus tangent squared A. So that we simply substitute. Secant used to be here, and now it's tangent. Well, yeah. And then we simplify. The negative 64 goes in and subtracts to 3, gets negative 61. Negative 64 tan squared A has nothing to combine with. Same with 132. And we substitute. Let's say that tangent angle is equal to some value called B. So then we, after moving the tangent A and turning it here, tangent A turning it here, and the constant stays unchanged, we have this function. You could quadratic, or you could go into TI-84 and find the zeros. Yeah, the 2 zeros, because you can hit it at 2 angles. These are the zeros. So now we have that tangent A equals 3.88 or 2.2457. Arctangent both values, and add or subtract 180 as necessary to get within the first quadrant. Well, actually, it would actually be it would be 180. Sorry, do whatever you need to do to get into the first quadrant and have a coterminal angle. A is equal to 75.55 or 13.80. These are the angles that work.